In this episode, we're going to explore a place where security and software development meet, because that meeting point is where a lot of modern risk lives. CI/CD stands for Continuous Integration and Continuous Delivery, CI/CD, and it describes a way of building and releasing software where changes are integrated frequently and delivered through automated steps instead of slow, manual releases. For beginners, the details can sound technical, but the core idea is simple. A pipeline is a conveyor belt that takes new code from an idea to a working product. When a pipeline is secure, it helps prevent accidents and block attackers from slipping in malicious changes. AI assistants are now being used to speed up parts of this process, like suggesting code, writing tests, summarizing changes, and helping people review work. That can be helpful, but it also introduces new risks, because a fast assistant can amplify mistakes or normalize unsafe shortcuts. The goal today is to understand what a secure pipeline looks like, why tests and change control matter, and how to manage AI assistants so speed does not come at the cost of trust. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Continuous integration is the practice of frequently combining code changes into a shared code base, so problems are found early instead of piling up. Continuous delivery is the practice of preparing those changes for release in a consistent, repeatable way, often with the ability to deploy quickly. Together, CI/CD creates a system where many small changes flow through automated checks and build steps. Security is deeply connected to this flow because the pipeline decides what gets built, what gets tested, and what gets released. If an attacker can influence the pipeline, they can potentially influence the software that ships to users. Even without an attacker, a weak pipeline can let risky changes slip through, creating vulnerabilities or outages. A secure pipeline aims to ensure that only authorized changes enter, that changes are tested and reviewed, and that the pipeline itself is protected as a high-value asset. When AI assistants are added, they become part of the process that shapes changes, so they must be managed with the same seriousness as any other tool involved in building software. A pipeline is made of stages, and you can think of each stage as a checkpoint on that conveyor belt. Early stages might check that code is formatted correctly or that it compiles without errors. Middle stages might run automated tests that verify the software behaves as expected. Later stages might package the software and prepare it for release to users. A secure pipeline also includes security-focused checks, like scanning for known vulnerable components, verifying that secrets are not accidentally included, and ensuring that builds are created in a controlled and repeatable way. The pipeline is powerful because it can enforce consistency, but it is also dangerous because a single misconfiguration can affect every release. AI assistants can interact with these stages by suggesting configuration changes, generating scripts, or recommending which tests to run. The safe approach is to treat AI suggestions as proposals that must pass the same checks and reviews as any other change. One of the biggest risks in CI/CD is that the pipeline becomes a shortcut around normal security controls. If a developer can push a change and have it automatically deployed, then the pipeline is effectively granting that developer the ability to change production systems. That might be appropriate in some environments, but it must be intentional and controlled. Attackers know this, which is why pipelines are attractive targets. If an attacker steals credentials or compromises an account, the pipeline can be used to ship malicious code that looks like a normal update. A secure pipeline addresses this by limiting who can approve releases, separating duties for high-risk changes, and requiring reviews before critical actions. AI assistants can accidentally encourage shortcuts by making it easier to generate changes quickly, so a key discipline is that speed should not reduce the number of checkpoints. The pipeline should remain a gatekeeper, even if the assistant makes it easier to reach the gate. Tests are one of the most important guardrails in a pipeline, and beginners can think of tests as automated questions you ask the software to make sure it still works and still follows rules. Some tests check functionality, like whether a feature behaves correctly. Other tests check safety, like whether input is handled properly and does not create obvious vulnerabilities. Tests matter because humans are not good at catching every edge case when reviewing code, especially when changes are frequent. AI assistants can help by generating tests, suggesting missing cases, or summarizing what a change might affect. The risk is that AI-generated tests can be shallow, misleading, or focused on happy paths while missing the tricky cases attackers exploit. A secure approach treats tests as evidence, not decoration, meaning you want tests that actually challenge the code and fail when something is wrong. That requires human judgment, especially for security-critical behavior, because security problems often hide in rare conditions rather than common ones. Secure pipelines also depend on protecting secrets and sensitive information, because pipelines often need access to systems, keys, and deployment credentials. If secrets leak into code or logs, an attacker can reuse them to access systems later. AI assistants introduce a specific risk here because they can suggest code that includes placeholder secrets, or they can encourage copying and pasting content that accidentally includes real credentials. Another risk is that people might paste sensitive data into an AI assistant to get help troubleshooting, not realizing they are sharing something that should remain private. Managing this risk is partly about training and policy, but it is also about design. Pipelines should minimize where secrets appear, limit who can access them, and avoid printing sensitive values in logs. When AI is used, it should be used within rules that prevent sensitive content from being shared and within systems that handle data carefully. A beginner takeaway is that secrets belong in controlled storage and controlled access paths, not in the code or in casual messages. Change control is the discipline of managing how changes are proposed, reviewed, approved, and tracked, and it becomes more important as pipelines move faster. Without change control, you cannot answer basic questions after an incident, like who changed what and why a particular version was released. Change control includes requirements like peer review, approvals for high-impact changes, and records of the final decisions. It also includes versioning and the ability to roll back, because even good changes can cause unexpected problems. AI assistants can help change control by summarizing changes and highlighting potential impacts, but they can also undermine it if people treat the assistant's summary as proof that a change is safe. A secure approach uses AI to improve understanding, not to replace responsibility. The human approver still owns the decision, and the pipeline still enforces the rules, so a change cannot skip the required checkpoints just because it was generated quickly. A critical idea in secure pipelines is trust boundaries, which means knowing where you trust inputs and where you do not. Code changes from a known, authorized contributor might be trusted more than changes from an unknown source, but even trusted contributors can make mistakes or have compromised accounts. Dependencies, like third-party libraries, are another input, and they can carry hidden risk if they include vulnerabilities or malicious content. Build artifacts, meaning the packages produced by the pipeline, must be traceable to the source and the build process, so you can trust that what you deploy is what you intended. AI assistants can influence trust boundaries by generating code that looks correct but includes unsafe patterns, or by suggesting dependency changes that bring in risk. A safe mindset is to treat AI output as untrusted until it passes the same validation as any other input. The pipeline's job is to make those validations consistent and hard to bypass. Another common risk is configuration drift, where the pipeline and its rules change over time in small ways that nobody fully understands. Because CI/CD systems are often configured through files and scripts, small edits can have big consequences. AI assistants can make it easier to propose configuration changes, but that can also increase drift if changes are made quickly without careful review. This is why pipelines benefit from treating their configuration as a high-value asset, with restricted access, peer review, and clear ownership. When configuration is managed like code, you can track changes, review them, and roll back if needed. You can also enforce policies that reduce surprise, like requiring approvals for changes to deployment steps or security checks. Beginners can think of this as protecting the rules of the factory, not just the products coming out of the factory, because if the factory rules are compromised, every product can be compromised. As we close, the main message is that managing CI/CD with AI assistance is about balancing speed with control and doing so in a way that keeps the pipeline trustworthy. Secure pipelines enforce checkpoints through testing, scanning, and consistent build steps, and they treat the pipeline itself as a high-value target that must be protected. Tests provide evidence that changes behave correctly and safely, but AI-generated tests still need human judgment to ensure they are meaningful. Change control ensures that decisions are reviewed, approved, and traceable, and AI can support that process without replacing responsibility. When AI assistants are used wisely, they can improve clarity and productivity, but they should never become a reason to bypass reviews, weaken checks, or blur accountability. A secure pipeline is not just fast, it is predictable, auditable, and resilient when something goes wrong. And that is the standard you want as software and security continue to move closer together.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.